This is the first in a series of videos that we're going to create to show you how to make some really cool things on the Creation Station. We plan on creating one of these videos a week throughout the project until the last unit ships. So if you have any ideas for videos of things that you want to see made on the Creation Station, you can even send us your original design files if you want to have them featured. Just send those requests to info@creationstationcnc.com, and if we like your idea, we'll feature it on one of these videos. For this week, we're going to create this 3D printer spool rack. This is an early prototype that we made. It's made out of 1/4 inch and 1/2 inch MDF. We're going to make ours out of 1/2 inch plywood to give it a little more beef. So let's take a look at how we do that. So in order to create a design on the Creation Station, it takes 3 steps. First, you need to create the design that you want the Creation Station to make. The second is to convert that design into G-code. And the third is to actually run the G-code on the Creation Station to actually make your design. So I'm going to open up the Cut2D software, which is one of the bundle options that we offer to include the Cut2D software. And the Cut2D software allows you to do the first 2 of those steps. It allows you to create a design and convert it to G-code. If I wanted to create the design here, I could just click on Create a New File, specify the size of the material I want and the thickness, and then hit OK. And then use these simple drawing tools to create whatever shape I want. I could specify the location and size of this object. I can create different shape objects. I can combine multiple objects by selecting them and using this Combine tool, and now they become one object. I also have this polygon type object to create whatever shape I want. And then I could specify how I want the Creation Station to cut those shapes. But to save time for our purpose in this demonstration, I'm going to open up the design that I created in a simple drawing program. In this case, I created this design in Adobe Illustrator, but there's also a free open source version or software called Inkscape that allows you to do essentially the same thing. So once you open the design, it automatically creates a workspace for you. I'm going to make the workspace just a little bit bigger to make it a little easier for us here, and tell it the thickness of the material I'm going to be using is 1/2 inch. So once I do that, there's my design, and I'm going to select all of these objects and just move them away from the edge a little bit here, just to make it a little easier for us to see the tool paths when I create them. But normally you would just leave them right up against the edge. So the first thing I'm going to do is I'm going to select the first things that I want to cut out. So I'm going to cut out these circles here for the piece of dowel rod that are going to hold the spindles in place. So I'm going to open up the Toolpaths tab and hit this little tack here, otherwise it'll keep automatically hiding this Toolpath tab. And I'm going to click this Create Profile Toolpath. And a profile toolpath follows the line of the shape. So you can specify either along the outside of the shape, along the inside of the shape, which is what we want in this case here, or directly along the path itself, right in the middle. So we want to go inside. We want to tell it our depth is going to be 1/2 inch. It's going to start cutting at 0 inches from the surface, or right at the surface. And we can select the tool that we want to use right over here. So you have all these different options. I'm going to use the 1/4 inch end mill for all of our cuts in this project, and then hit calculate. And you'll see that the software automatically calculated how the tool path is going to move, what it's going to do, how it's going to cut out these shapes, and it previews that for you. If you hit the preview button, it'll actually show you what it'll look like if when that shape is actually cut out of the material. So you'll see you have this little tiny leftover tab, which is very small, and it'll, once it cuts through the router bit, will probably kick it out of the hole. But it's too small to worry about. The next shape, however, these larger pieces we will have to worry about that piece coming out, and I'll show you that in a minute. But first, we need to cut that shape out. So again, we want to go along the inside. We want it to be a 1/2 inch thick, and then we want to set these tabs. What these tabs do is they will hold the piece in place when the cutting is done. So I'm going to hit Edit Tabs, and then this will allow me to insert the tabs where I want them. And once I get them all in there, we can see the preview, and it'll show us what these tabs actually will look like when the material is cut. So I'm going to hit Calculate. These are the cut paths that'll happen. If I hit Preview, it'll show us what it'll actually look like, and you can see the tabs there, which will hold the material in this piece in place so that it won't go flying across the room and potentially break something or hurt someone. Okay, so that's that piece. Now we want to cut the actual trusses out themselves. So we're going to select those and hit Create Profile Toolpath again. This time we're going to want to go along the outside of the shape, not along the inside. And we're going to again keep the same toolpath or tool and depth, and we're going to add tabs again to keep the thing from flying. And just right about here, 2 per shape, and calculate. And now we can preview that and see what it'll actually look like. And there you go. Those are the trusses. And once these are cut out, you could just use a razor blade and slice those off very easily. Maybe you give them a little sanding to smooth them out, and you will never know they were there. Okay, so now we need to do the base. The base consists of one large piece with slots cut into it. Not all the way through. We will only want them deep enough for these trusses to slide into. You'll notice that I made these rectangles a little wider than the base itself. The reason for that is the router bit, well, if it stopped right at the edge here, the router bit has a radius, and you wouldn't get a nice smooth square here, and you'd have to cut that out with a razor blade, which is kind of a pain. So if you make the rectangles a little bit larger, the router bit comes out, and you'll get a nice smooth corner here. So I'm going to select all 4 of these rectangles, and then I'm going to click Create Pocket Toolpath, not a profile, but a pocket. And we are going to specify a depth. I'm going to make it 0.2 inches, and a 1/4 inch tool again, same tool. And there's no need for tabs because we're not going all the way through the material. And we're going to hit Calculate and Preview, and we'll see what that actually looks like when it runs through. Okay, we're trying to keep the pieces all nice and close together so we waste as little material as possible. So the last step is to cut the shape out, the actual base out itself. So we're going to go to, again, a profile toolpath, cut along the outside all the way through, so 1/2 inch thick, and we're going to add a couple tabs again just to make sure this piece doesn't go flying once it gets loose. Okay, and calculate and preview, and that's what our final object is going to look like once we're done cutting it out. So if we want to see the whole thing, we can hit Reset Preview and preview all toolpaths, and it'll run through the entire program to show you what the Creation Station will actually do for this project. So now that we're done with that, the last step is to actually save our toolpaths. So we're going to hit Save. We're going to select the toolpaths that we want to export, which in this case is all of them. We're going to select a post processor. We're going to want the G-code arcs in inches post processor, and you'll notice there's a bunch of different post processors for different machines. Our machine, the Creation Station, just uses standard G-code, so there's no need for any special post processor. So we're going to hit Save Toolpaths, and we're going to call it spindle spindle holder, and I'm going to add the extension NGC because that's the type of extension that the Creation Station uses, not the .tab, which is the default. That's just a simple modification that you have to do in order for this to work. So I'm going to hit save, and it's going to save that to a thumb drive that I have plugged into my machine here. And then I'm going to remove that thumb drive and take it to the Creation Station, the machine controller machine. Okay, for the next step, we're going to load up our G-code file that we created in Cut2D on our machine controller machine. Now, before I do that, let's talk about the machine controller. The machine controller is a computer that directly drives the Creation Station. Now, we have it as a separate machine here, but you could use your existing machine, whether it be a desktop or a laptop, to control the Creation Station. We also recommend the Linux CNC software. It's free, it's open source, it's powerful, it's easy to use and install. But there are also Windows alternatives that are commercial that you have to purchase. Linux CNC, though, is very low requirements for the computer. The minimum requirements are a 733 megahertz computer with 256 megabytes of RAM minimum. So those are specifications that you could probably dig up an old computer that has those specifications, or even better. You know, the monitor, we have an LCD here, but people are trying to get rid of those old CRTs. An old CRT would be perfect here. An old computer also is great here because if you're doing cutting metal on the Creation Station, and you got metal chips flying around, you don't want your fancy, expensive laptop or desktop, you know, to have metal pieces in it. Whereas if you've got it for free, it really doesn't matter so much. And it's always good to recycle. So let's move on and load up the G-code file that we created. So we're going to go to, there we go. The next step is to home the machine. So I'll enable the machine, and then I'll use the arrow keys to position the machine. Right now the jog speed is set quite low, and I can manually set that all the way up to its maximum speed. So we'll bring that router head to the top corner of the material, and we'll also lower the bit down until it's just touching. Now, one of our stretch goals is a sheet of material that you can use, that, like, for example, this sheet of stainless steel here, that you can put right under the bit till you feel it give some resistance. And this sheet of stainless steel is 5/1000ths of an inch. So I can then specify to move the head only in steps of 5/1000ths, and then hit the minus button once, and now it should be touching the top of the plywood exactly. I'm going on to each of these axes, hitting home, and specifying that's the home position for our router bit. I'm also going to press the touch off button, which will tell the computer that I've touched the tip of the router bit to the material on the Z-axis. So that you'll notice it changes the display a little bit to reconfigure the height of all these cuts to match. So the next step is to actually run our G-code. So I'm going to hit the play button here on the computer, and I'll get a message saying please insert tool number 1 and press continue when we're ready. As soon as I press continue, the execution will start. Okay, so I'm going to hit the continue button now. Okay, now we've got all the pieces sanded. All we have to do is take our trusses and insert them into these slots, probably with a little wood glue, but I'm going to leave the wood glue out for now. And they fit nice and snug, which is good. And there we go. Just add a little bit of wood glue, maybe tap them down a little bit with a hammer, and then cut a piece of dowel rod for the spools, and you're all set.